Okay, so in this video, we will be going over arrays. Now, in the pointer video, I went over a lot of this, so probably not going, to be going into full detail. Um, but I will be, pointing over a little, pointing over. I will be going over a little bit about how pointers work, how they're structured, different types. Um, all right, so let's see. Oh, we'll go ahead and actually, do I have? Do have it? Oh, all right. Apparently, I still have those. Okay. Put that over there for now. Okay, so this was the example used for the the pointer structure. Um, but I will go ahead and use it. And I will use a dark green. I don't think I used that yet. All right, cool. So, we'll just say that that is right here. All right, and this is going to be our array. So, give me just 1 second. Someone's messaging me. And, okay. So, yeah, this is our array here. And, uh, it's going to work similar to the class. You'd have a pointer that is going to point to this somewhere else. Like for instance, we can say that instead of pointing to this guy here, where it was, originally pointing, I can point to, let's call it 0x4000. All right. And that will be this location here. Oops. That we that we have here for our array. And let's see, use purple. So I'm actually going to go all the way around here and point to that to indicate that this, instead of pointing to this, is now pointing to this, since we've changed it from 0x1000 to 0x4000. All right, so now we're pointing to a completely different area of memory, and that's the area where we're going to have our array set up. And let's see, here it is. I just opened. Okay, so we'll go ahead and right. I have to extend it. Already had this problem once. All right, so this is going to be our array. Okay, so how does this work exactly? Well, the most common type of array, we're going to, once again, let's make this way smaller. This is 0x4000. All right, and down here, 0x0. Okay, so Um, the offsetting system is going to work, the same way as it did with the class. But it is going to be referenced a lot more, and it's going to be indexed uh, in a slightly different way than the classes were. So how exactly is this going to work? Well, let's see. Gonna get really, really sloppy looking. See if I can. This is gonna get sloppy looking no matter what I do. Whatever. All right, whatever. We'll try and keep these somewhat same size. I don't really care too much about that, but yeah. Okay, good enough. All right, so um here we have our array, and this is going to indicate, let's see how many we got here. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we have 8 different um, indexes here that we can use in this array. And once again, our offset here is 0, starts at the beginning. And we're going to be using int 32s. So each one of these blocks here is going to hold 32 bits or 4 bytes. All right, so if we did it like the classes, then we could just go like this and just say that this is 0x4 here, and then this is 0x8, and this is 0xc, this is 0x10, 0x14, yes, 14, 0x18, and 0x1c. All right, so you can see that, it's the same alignment that we did with the class, but how do we actually get that? We could reference that every index is equal to this offset, but that would take, much more time. So how do we do this? Well, we know that each of these is 4 bytes. That means if we offset by 4 bytes each time, we can get the next value. So what we can do is we can say var multiplied by 4. And what is that going to do? Well, var is basically going to be our offset, or commonly called our index. So our index is going to be, let's say 0. So 0. 0 multiplied by 4 is 0. That would be right here, right? Okay, so, and then let's say it's index 1. Index 1, 1 multiplied by 4 is 4. That would be right here, right? So, moving on, 2 multiplied by 4 is 0x8. Now remember, this is hexadecimal, 0x4. It's not just, 4. I mean, they are, similar. I mean, they will show up same in a lot of cases, but they are different. But yeah, moving on. Let's see, what is our next one here? 3? Yeah, 3. So 3 multiplied by 4 is what? Well, if you looked up the hexadecimal video and you learned how it works, then you would know that it is C. All right, so the next one here, C. And this will, continue the same way if you have, thousands and thousands of different indexes in an array. And, that's how you can get that value. But yeah, this is the most common type of array that is used. And for those of you that don't quite understand how this works, it's basically it starts out at 0, but then this 4 that we're multiplying it by, it basically puts it in multiples of 4. So it's basically, instead of going 0, 1, 2, 3, and then 4, it's going to be going 0, 4, 8, C, and so on and so forth. But yeah, this is, like I said, the most common structure. And it doesn't only hold, like int 32s, and it also holds all kinds of others. For classes, like if you have a array that holds classes, it works the same way, only slightly different. We're going to be holding a 32 bit pointer in each one of these areas here instead of a whole class. So when you add the when you create the class, it's allocated somewhere in the area that we have to work with in memory, and it takes that location that it's in memory, and it will save that to the pointer that is in here. So if you want to access a specific class, then like let's say you wanted to access index 2 in the class array. Okay, so what would happen there? Okay, so be 2 multiplied by 4, which is 0x8. So that means we'd be right here. So we have our position. We'd read this data here as a pointer location. That pointer location would then be taken and parsed to wherever it needs to go and say, hey, this is the class you wanted. And then we could use what we did in the previous video and use the offsets to get specific elements inside that class. Your variables and stuff that you have in there, are all going to be in the same offset position. I mean, that might change when you recompile the file, but if you have the same file and in most cases, I should say, this will be it. Because, I mean, it's a program and people can do whatever the hell they want with it. They might, specifically change classes to change in that way, that it, doesn't work. But, the class is going to be, in most cases, parsed from the array in that way. Programming is whatever you can get it to do, you can get it to do. So there are programs that use specific techniques to hide itself in memory, and each time it's used, it relocates itself in memory to make it harder to find. They use encrypted formats and stuff for values and pointers. There's all kinds of different techniques that are used. None of this is uncrackable because, if somebody knows how to read the assembly code, they can just say, oh, this is where this goes, that goes to there, blah, 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 and, basically reverse engineer it. But yeah, that is the most common type of array here. The next array I'll be going over, and I'm probably gonna make this my class, 'cause I'm probably gonna have to go. But we'll say that we're going to have a linked list here. All right, and whereas this was like an offset 4 here, this is gonna work differently here. And I'll go ahead and put it here. Put them both here. All right, so we'll make it the same color though. Okay, that we're the same area. Okay, we're gonna say that this is the same area we're using instead. They can't both be in the same position, but yeah. So how is this gonna work? Well, a linked list is more like a dynamic list. As we need more memory, we can get more memory. And if we don't need something anymore, then we can just say, hey, we don't need this, and boop, just free it, and free some space. Whereas this one here, this whole thing is allocated. We can't just say, okay, I don't want 0xc anymore here, so I'll just get rid of it. That doesn't work with this. So with this one, I've represented it in the same way I represented this one, but it's actually not going to be like that. So it will be changed shortly. But what is a linked list? Let's go over that a little bit here. The best way I explain to people how linked lists work is to describe it like a train. Now, a train will have a a main engine, and we call that the starting point. Okay, and each one of these cars that's connected, coupled to the next car, it makes it longer and longer and longer. So, if I was to visibly write this, it would look, like this. These two connected here, right? Okay, so we'll say that this is the main engine and this is the car it's connected to. All right. Now, a linked list, it's basically going to be using kind of like a pointer structure that we used in the previous video. If you haven't watched the previous video about pointers, I do recommend you do that. Otherwise, you will be confused about pointers because I won't be explaining those here. But yeah, in here, pointers, will be a big thing. So you probably want to know that. And I'm actually going to open up another paint here. I'll put it down here. And I'm going to show the structure of this list link. And it's going to be a structure that we'll use a class for this basically. So let's see, I'm gonna make it black. Okay, so how is this gonna work here? Well, that depends what exactly we need. For this one here, that was relatively simple. But this one here, this gets more complex. So I'm gonna make a class here. Actually, I gotta switch keyboards because that keyboard does not work properly. Some of the keys I'm going to press. All right. So we'll call it class linked list, I guess. Linked list. I'll call it linked list, I guess. All right. So here we have keyboard will work properly here. There we go. Here we have our linked list class, and they're messaging me. Wait. Okay, so 1 second. Mute this really quick. can. This piece of shit. Hold on. Okay, so my thing is fucking on. Shit. Hold up. This is Windows 7 trying to be helpful, and it's not. There we go. Oh, sorry about that. Uh, People were doing stuff and I couldn't really hear. All right. Okay. So how is this going to be set up here? Well, in our linked list, we need a couple of things. Like first off, we need to have what exactly are we linking here? And we can do this multiple different ways. From our last video, we had a class character. I can just use that here. We'll pretend that exists here. So we can do, we'll say, yeah, we'll just say that. All right, so we'll say that this is what is going to be, uh, you know, in the array here. All right, so this is going to be an array that stores characters. All right, so we have that, and remember that this car here is going to be uh, a, uh, a pointer. If watch the previous video, then you can understand that. So moving on here, we're also going to have another pointer here, which isn't going to be labeled as a pointer either. It's going to be labeled as a class here, and the class will be the linked list class. And I'm going to refer to this as next. Okay. So what have I done here? Okay, I have 32-bit value here and a 32-bit value here. Remember, because these are pointers and they're 32-bit. So I can just split this down the middle here. And in here, it's way too big. In here, we have, I used the right capitalization for it here. We have car. And in here, we have next. Okay? So, how does this work then? Well, somewhere we're going to have a class that's going to get this information from these, but the way this works is the same way of the train. So we're going to have right here car that's going to hold the character pointer, that we're trying to store in the array, and this next here is going to hold a pointer that is going to tell us where the next car is in the train, right? So we'll say that right now we are right here, and we want to get to here, right? So how do we do that? Well, let's see. We were at 0x4. Okay. So 0x4. Okay. Now this here is 4 bytes, and this here is 4 bytes. So that means we get to offset by 0x8 if these are right next to each other. So I'll say that these are right next to each other for now. 0x4008. Okay? So what are we going to have to put exactly to get, to this area here? Well, in this one here, which we're going to call the main engine here, we're going to have to put inside the next the value for the next car. So inside of here, next is going to be equal to 0x4008. Now it basically says that after we get this character, or if we even need this character, we might not need it. We might just be stepping through the indexes. So we finish up with what we want in this one, and then we go to this next here and we say, okay, let's go to the next. And it's like, okay, so next is 0x4008. Okay, so now we're here, and I'm actually just going to copy these, paste it. Okay, so this next one we're at here is going to be an area that is actually different in memory. Now, a linked list does not require it to be in the same area of memory. It puts it wherever it's available to put that memory. So we could also have stuff up here, let's say. Okay, so we'll say that we also have parts of our array up here. All right, so put it right here, and we're gonna say that that position up there, I'll write it here actually for you. 0x, whoops, change black. 0x, we'll say 5,000 just to keep it even. Scale is awful on this one here. You can see because the way it goes up doesn't make much sense as far as spacing, but we don't care about that. So this here is going to be at 0x5000. So like it's a completely different area of memory that it was allocated to, because let's say that at position 0x400C, which would be right after this, let's say that it put something else because this wasn't created yet, so it just put that there. So it couldn't put it in that position, so instead we had to put it at the next free position, which is 0x5000. All right. So now we're here, and that's what we have here. We have to fill this out in order to get to the next area we want. Okay, so 0x5000, right? So now we've basically said that after we're done here, doing whatever we're doing with the character, if we even needed it, we might just be passing over. We get next, which is our pointer, and that says 0x5000. It's like, okay, so I want to go to that area in memory, and that is our next one. All right, so we're going to the next one now. If it will hit the button, there we go. There we go. And as you can see, I'll put an arrow there to indicate that's the direction we are going. And you can see that this can continue going on and on and on and on and on, because we don't have to say what we were previously connected to. We only have to say what we're connected to next, since the first one is going to know something else is going to tell us which one this is. And once we have this one, then we can just use that next and say, okay, the next one is this one, and then the next one is this one, and so on and so forth. So on and so forth. This will continue. Uh, so I'm not going to be going over specifically, how all of this is written. I may do a quick example here. I'll do a quick example, I guess. Okay, so we'll say we have class, uh, what do we call it? Let's call it town, all right? So this is our town here, all right? And for the first example that we used, we were just using a int array, and we could say that is maybe we'll just use waste of space because I can't think of anything right now. All right, so uh, that right there uh, is our waste of space array there. But this is actually not going to be taking up, like the full size of the array because we don't know what the size of the array is, right? So what is it going to use instead? It's going to use a pointer. And right now this pointer is set to 0x0 because at this moment in time, this array is not pointing anywhere because it doesn't exist, right? It's a null. Okay, so and then the next one here, we had a character array. And we'll just call this characters. Okay, and this is the same way as the previous one. We don't know the size of this. So all that's being placed in here is the pointer that's going to point to that location when it's created. All right. And the next one here is we'll use linked list. And we'll just call it list. Okay. And same way here. This one is only taking up 32 bits of space because all it needs to put is a pointer. And that pointer is currently 0x0, all right? So we'll say that it has a constructor here. And oops, when it goes to the constructor, it will create an actual array here. We'll say it is a size of 8, since that's what it was in our example here. All right, so what does this do at this point? All right, so at this point right here, not the whole thing, just this part right here, this is allocating space in memory for our array. And it needs enough space to hold the whole thing. Now remember, it is a int32, and that means it's going to take up 4 bytes for each index. So in order to get how much space we need, really quickly here, I'm going to go back up. I needed to, yeah, up here it is. Okay. So up here, we have to be within the bounds of our array. I mean, for instance, if we went out here, for instance, let's see, do I have a calculator open? I don't know if I do. All right, okay, set this to programmer, hexadecimal. Okay, so Where is Notepad? It was, oh, it's right here. It's the same one, I forgot. Okay, so our var here, is var multiplied by 4, right? Well, what if we do 8 multiplied by 4? Okay, what is 8 multiplied by 4? 8 multiplied by 4, remember this is hexadecimal, is 20. Okay, so that means that if I access that area, I'd be accessing 20. 20 is right here. And that means that it would be reading data outside of an array. We can't do that, right? All right, so what can we use with that then? We can use that to say that that is the amount of space that we are going to need for this array. So it can use that calculation, the size that we're making the array multiplied by 4 if it's in, 4 byte, segments there. We can use that to say that's how much space we're going to need. So in here, I can say that we need space of 0x20 in order, for this to be made. So it has to allocate that much space. Once that space is allocated, it's going to have a location where it saved it in, memory, wherever it saved it at. And we have that value. That value is saved to this pointer right here, waste of space. All right, so it doesn't actually appear to be a pointer, right? I went over that in my previous video. It is indeed a pointer. So, yeah, you can look that up if you want. Not going to go over that here. Okay, so our next one here, oops, our next one here, we're going to be creating a array of, characters, but it's not actually going to create the character classes, just the space, the space for those pointers. So let's see, what is it, characters? Yeah, characters is equal to new character array, and we're going to make it 8 again here, just be the same. All right, so since this uses int 32s, 4 bytes, it's going to be the same as this. It's going to be 4 multiplied by the size of the array, and it's going to give us, once again, 0x20, and we don't need to, do that because we already know. So, same size. Now remember, these are just the pointers here for, the character. In here, these are the values, right? We don't need to have a pointer to each of these, for this here because it's an int array, and all we need to do is read the values. But for this one here, we don't have enough space to put our full class here in 32 bits, so we have to put it in a actual pointer format here that we can go to a space in memory and say, okay, I can put this here and I can put this here. The characters classes might be all throughout memory, but the thing that will remain the same is that they're all going to be referenced by those pointers, and we'll be able to find them. Okay, so once again, let's see. All right, we're going on to our linked list here. Okay, linked list. Oops, I don't need to type linked list. I just need to type list. All right, list is equal to new linked list. And this could be done multiple different ways. But for this example, I'm going to try and keep it simple. So that's basically going to be the train engine here. Remember, down here, this was our main engine. This is where we start, right? This is going to be the start. Okay, so we're at the start, and I'm I'm gonna put start here. And down here, whoops. Come on, keyboard, work with me here. Keys don't want to work. Okay. All right, so we have a function here, start, and basically we're going to use this to go down the line, and there's different things like catches and all that. But for the sake of this, I'm only going to show going through. So how is this going to work? Oops. All right, so we have our list, right? And the starter point here. I don't want to overwrite list because list is the starting point. If I erase the starting point, then it's gone. Okay, so I'm going to create a new linked list item here. And I'm going to call it current. So current is going to be equal to let's see, yeah, we'll make it a new linked list. Okay, so actually wait, that would be for the other part. I'm not going to do that actually. That's for creating the list. This is going to be for reading it, so I won't put that there actually. Okay, so we're going to set current equal to list. Now, what does that do? That takes the pointer in list that says where it's at, and it's going to put it in current. That means both of these are pointing to the same class, okay? So from there, I can put while current, and remember current is our, the current linked list we're working with in our class here. All right, see, while current is not equal to null, that's basically saying, if current is valid, basically, it's been created, right? And we're also going to say, actually, we won't put that there. All right. So in here we have a loop, right? And this is going to continue until current is equal to null. All right. So in here, we currently have current set, so we can do current dot character. Is that what it was called? I actually forgot what I called it. Car, sorry, car. Current dot car, and we'll say that it had, a variable called health inside the car. Excuse me, the character class. So we can set to 50 here. All right, and then after we're done with that, we can go current dot next here. And remember, current dot next. What is current? Current is a linked list class. So we go to linked list class here. And remember, next is going to be that pointer that points to our next linked list. So down here, we're actually not, setting it in this case. We're actually going to be overriding current. So current is going to be equal to current.next. Now what does that do? That basically says, okay, we're going to go into the current linked list we're using, and we're going to go to its .next. And the .next holds that pointer position for the next one. So the next one would be the 0x4008. So that value there is going to be put into current, overriding that this pointer position here where this points to. All right. After we do that, we're going to go out here of the loop and come back up here and check the expression. And current not equal to null. Remember, current is equal to 0x4008, right? Which is our next class here, so we're not null. All right, so we're going to go back into here, and we're going to, do the same thing for this, class, set it to 50. And then inside of here for this one, it's going to get its next. And its next is going to tell us to go to the next position. And our next position is 0x5000. So it now sets our current to 0x5000. We go back out of the loop, come back up here, go to the expression, current not equal to null. Current is not equal to null. So we go into here, current car dot health. We're setting the health. So that means we've successfully set this to 50, this to 50, and this to 50 for the health of each of the characters here. And we're here now, right? So we're going into current.next. Now we didn't actually write this here for what this is equal to. That's because I didn't actually set next. Next is equal to null. So that means that it's setting a 0x0 to our current. So once we come back out here and we go back up here, current not equal to null, current is now equal to null, meaning that we now exit this loop. That means that we've gone through the whole linked list structure here and successfully completed what we wanted for each of the elements. And then we exit it. All right. So that is how we read from the list. Now, how do we create the list? Well, let's see. We'll have. Whoops! I did not do this right here, did I? There we go. That is not a constructor, so it needs to have the proper return. Let's see. What should we call this? Public void add new. Let's do that. Oops. Okay. So here we are. And this function here is basically going to add a new linked list element here. So I am going to make this simple on myself and say that this is going to be a linked list type, and I'll call it temp. You can call whatever you want. It doesn't matter for the name as long as it doesn't conflict with anything. Okay, so what we're going to be doing here is we're going to be finding the end of the list, and then we're going to add on to that last element here. Okay, so how are we going to do that? Well, I am going to copy my previous code here. And remember, we're setting list to current here. That's going to hold the value that list held. We don't want to modify that list, because if we modify that, then it's gone. Okay, so we're going to go into here. Well, current is not equal to null. Blah 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 blah. Okay, so I am going to do this exactly. There's lots of different ways to do it, but how am I going to do it? Let's see. Well, let's think about what we need here. This is going to be going through a loop that once it reaches the endpoint, it's going to take its .next, and it's going to be setting it to the new linked list element that we're putting. All right, so let's see. How would we do this? It's probably isn't the best efficient way to do it because I'm not really thinking too much about that. But let's see. I'll put if current is not equal. Actually, no, let's do it this way. If current is equal to null, then we're going to go into here and we're going to be setting list equal to temp. What is that going to do? That is basically going to say if we got out of list a 0x0 that was put into here, that means that we don't currently have a linked list element. That means that maybe everything has been deleted. So we need to create a new list, right? And we can use that temp. We don't have to create a new one. So we can just overwrite the pointer position for that. And now this temp is our new, engine here. That would be the first one. All right. It may not be at position 0x4000. It's probably going to be at a different position in memory. I mean, it could be in the same place if you have just been deleted and it's been put in the same place, but most likely it's going to be in a different area of memory, but I'm not going to change all that. But anyway, we have basically a fallback if it's not set to anything, then we have successfully added it. And after we're done with that, we can just do a return because we don't need to do anything else in here. We're already done. Otherwise, we now know that current is not equal to null. So we'll set current dot next is not equal to null. And we don't actually have to do any health changes in there, so we can remove that. What is this going to do? All right, this is basically going to do a similar thing to the previous one up there. This one is going to take the current linked list we're on. It's going to take dot next, and it's going to check and see if that is not null. If that is not null, that means that there is another element that we need to go to. Remember, because we're trying to get to the end. So we go into here and we go current dot next, which is going to get our next element, and it's going to set that to current. All right, and that's going to continue until current dot next is equal to null, right? So we can be sure that once we leave this, current dot next is going to be null, and we can put something there. So I can set that to temp. Now remember, we know that current is indeed connected to something because we got to this point. Because up here, remember, this current is equal to null, it would just set that there and then return. We're out of there. Okay, so we get past that position. We know that we're good on that being null. We can't be null there. And now we did a check here to make sure current dot next is not equal to null. So that means that this current dot next is going to have a valid value in it each time we go through it inside of this loop. And it's going to put that one in here. It's going to keep going. And at the point where current dot next is equal to null, because that's when we leave this expression from this loop, that's where we go on, right? So current dot next is equal to temp. Remember, temp is our linked list that we added. That's basically going to set the current dot next for this last element we have here, and it's going to set it to the pointer value that we have for temp. And temp is going to be whatever linked list we add into add new. So now we have that. So I can go into here, and I already forgot the name of it. What is it? Add new. Add new. Okay. So, add new. And here I have a function that requires an argument, because we have this linked list here, it doesn't accept, just like no arguments there. So there's different ways to do this. It depends on how exactly you need to do it. Like for mine, my linked list does not have well, it needs a constructor, but it does not have any arguments in its constructor. Oops. And we're gonna have to put that data in manually. So I'm actually going to do it outside of the function before it, or it can be after. It's going to be referencing the same thing, so I can do, we'll do character, let's say temp car is equal to new character. All right, now we have a new character there, and remember we need a new linked list item here, so I can call this, let's see, linked list is the class, we'll call it temp link, I guess, it's equal to new linked list, all right? All right, so after this is created, I can put something in it. So I can put temp link dot, what exactly was the name here? It was car. So I can go in here, temp link dot car is equal to temp car. Okay, now that would be taking that pointer value and putting it into car, which is inside of our linked list class that we just created. You could do it that way, but you don't need to do it that way because you're just making this extra bit of code here that you don't need. So what can you do instead? Well, if I created this class, it's smart enough to know what its type is, so I don't need to put a cast on it. It knows it's a character. So that means that I can just put this here. Now that says, new, character. It doesn't have any, arguments in the constructor. You could put arguments in the constructor to make it more, detailed if you need to put information in there. But now that character has a pointer link inside there. And, you could take this here now and copy that and put that into here. Not the whole thing, just that, sorry. And what does that do? That, remember this add new requires a linked list item. All right, and that linked list item we created right here. Well, we technically created it right here, and then we put it into the pointer right here. Okay, and then we've taken a character, which we don't necessarily need to do. Like if we didn't have a character here, then our functions down here would not work properly because this would not be a valid character, and it would say we can't go to this pointer position because it's at 0x0, and it's just going to crash because it's not allowed to access that in memory. So we could put checks in for that to make sure, but I'm not going to worry about that right now. But yeah, this new character put into car here, and if I further wanted to modify this now, I could go temp link dot car dot health is equal to 90. Okay, and that is going to go into our linked list, go to the character class that is currently pointed to, and then it's going to go to the offset position where health is at, and then it can change that to 90. All right, so that would successfully change this to 90 and add new here. All right, so we'd be taking that new linked list we have, and we'd be putting that at the end there, and then we go to the start. But then in here you see that this anyway is going to change all of the character's health to 50 throughout the entire thing. And I could go on more about this because it goes far more in depth. But was supposed to be a simple example explaining how arrays work, how they're structured in memory, and how you can better use them. A little bit more information on how they work, how pointers connect into all this. Another reason why we need pointers to help us have a more dynamic view of things. And without pointers, we'd basically be limited to a very simple block. We'd have to know every single offset for everything. We could use this technique here because this technique doesn't require a pointer because we just have to go offset it. But it can get really complicated, without pointers to get what you're trying to do done. And the invention of pointers, really allows us to do a lot more with our programs, a lot more dynamic, elements in our programs, that sort of thing. So yeah, a lot of good information to have, and I hope it was helpful, and I hope it answered your question. All right, I do believe that is it for this video. I didn't actually go over what the others look like for creation, but those are actually pretty simple as far as how they're, written. Each of the, in this character array, each of the, different elements for the indexes and stuff, they would all have to be set to a new character, and that would allocate a new space in memory for that new character that was created. And it would set that pointer to that position. I believe I went over that, just in case I didn't. All right, so I'm going to say that we are done here. I didn't go over everything I wanted to, but we are over an hour, and I was not trying to go that long. So we're going to end it here.